Hello, this will help you with problem number 33 of chapter 4. It's a long problem, and unfortunately this will be the second time I've had to do this video. Hopefully it works this time. I'm going to go through it step by step. It takes a while, and the one nice thing about this problem is that the steps that they make you go through are the problem solving procedures anyway. So in that respect, they pretty much just make you do all four sections, and then they have you do the fifth section, is just plugging in the numbers. So in that respect, it's what you should be doing anyway. But um, some of the things they ask you for are kind of odd. So let's go ahead and get started. First thing is a free body diagram. If you're going to do a free body diagram for this problem, I highly recommend you just go ahead and draw all the masses to start with. So you're going to have mass A here. I'm going to label it at an angle there because there are no forces off the axes, or they're on the x-axis or on the y-axis. So if I put it there at an angle, it won't get in the way. I'm going to have a force here of MB. I'm sorry, not force there, sorry. I'm going to have a label there for mass B. Why won't it delete? Huh. There we go. And then we have MC. Okay. Now, all three masses are on are being pulled by gravity because they're on Earth. So I'm going to have a force of gravity going down. Okay, now because the mass is all equal, the force of gravity will equal for all three, so I can just have them be the same length. And then they're on a table, so they have a normal force that's going to be equal to the force of gravity, but just in the opposite direction. I'm just going to label those all as Fn. Okay, that should be easy and straightforward. The next part is what's trickier. So we have a force pushing MA into MB, so we're going to have a force going to the right, and they call that F. So I'm going to go ahead and put an F there. Now, if A is being pushed into B, then it's not the force F that interacts with B, it's mass A that interacts with mass B. So I'm going to draw an arrow over here to the right, but that's going to be the force. Whoops, kind of hard to read that. Force. And you're going to write F of A on B. So the force comes from mass A, and it's acting on mass B. So you write Fa on B. Now from Newton's third law, we should know that if a force is acting on B from A, then there has to be an equal and opposite force. So I'm going to draw a force going to the left, and that is going to be F of B on A. So you can see the letters just switch positions and the direction of the arrow changes, but the magnitude of the arrow is the same. Now, the free body diagram for mass A is finished. We look at the free body diagram for mass B. We have B being pushed by mass A, which is being pushed by the force given, but mass B is also pushing on mass C, so you have a force going to the right. You label that F of B on C. Well, if there's a F of B on C, then there has to be an F going the opposite direction on B. So it'd be F C on B. Now mass C does not push anything afterwards. There's no mass D, for example. So there would be only three forces acting on mass C. There's no force going to the left. This is the free body diagram you should have when you're finished with part A. Now to go on to to part B, they're asking you to express the acceleration. Okay, explain what does the acceleration equal. If the sum of the forces in this case, the external forces, just equal F, then we can use that in our equation. You'd normally have A equals sigma F over m. Well, if that's the case, then we could rewrite that as the acceleration will equal the force divided by the sum of the masses. Okay, because M normally before is talking about the mass acting on the, or the forces acting on the whole mass. Well, the force is pushing all three blocks. So we're going to go ahead and rewrite that as A equals F divided by MA plus MB plus MC. That's your answer to part B. Now, for part C, they want you to express the sum of the forces acting on A, the sum of the forces acting on B, and the sum of the forces acting on C. Really simple, not difficult at all actually. You can rewrite the equation we had before, but this time you say sum of the forces of A divided by MA. Okay? So if that's the case, then we can substitute, I guess I'll use red. I can substitute A here, just like I had here. So I'm just going to set sigma FA divided by MA equals F divided by MA plus MB plus MC. If I finally isolate for the sum of the forces of A, you'd have F times, or actually you can do, it doesn't really matter, but I'm going to do MA times F. And then you have MA plus MB plus MC. That's one part of part C. Oops, I cut off the F. That's good. Okay, now we have to do this again, but for sum of the forces of B. So here is sum of the forces of B divided by mass of B. So you have sum of the forces of B divided by the mass of B equals the force divided by MA plus MB plus MC. You'll have the sum of the forces of B equals the mass of B times F, all divided by MA plus MB plus MC. Then we can go on to the sum of the forces acting on C divided by MC. So you have sum of the forces from mass C divided by mass C will equal the force divided by mass A plus mass B plus mass C. I'm going to scroll down a bit. You have sum of the forces of C equal MC times F, all divided by MA plus MB plus MC. Okay, now this still looks terrible. That's better. That concludes part C. For part D, I'm going to zoom out because I'm going to want E to be on the bottom part there. Yeah, so let's do this. I'm going to put D over here. Now, for part D, they're asking you to find the force of contact that each block exerts on its neighbor. Basically, what it's telling you to do is find the internal forces. You do not care about the external forces in this case, so that's why we're not going to be talking about F. We're talking about the internal forces. So if we look at the internal forces, we can actually identify them. I'll highlight them for you. We have this internal force here paired with this one, and we have an internal force here paired with this one. Okay, so we only have two pairs of internal forces. And if we wanted to express those, we could notice that the the sum of the forces of the sum of the internal forces on mass A would just be Fb on A, and the sum of the forces, sum of the internal forces on mass C would just be Fb on C, and Fb on C and Fc on B equal. So we can just explain it that way. We can just say, so I'm going to do C first in this case. The actually, technically, I should write out what we're looking for first. Sorry. So we have Sc on B. We want to know because that's an internal force from C on B, and it's the only internal force from C on any of the other opposite masses. We also want to know Fb, the internal ones. We'd have to know that's going to equal Fb on A plus Fb on C. We don't know what that equals. And then for A, we're going to be looking at Fa on B. So I'm going to focus on the first and third part. I'm not going to focus on the second part yet because, like we said, highlighting the green and the gold, these forces equal. So that's A and B was green. So this was green and this was green. And then these two were the orange color. Well, if I can solve for C and A, then I can just plug those two in for those green and orange parts, because although they're opposite directions, they're the same value, the same magnitude. So the sum of the forces on C will be equal to C on B. So I use the sum of the forces from part C to answer this. So I can just write Fc on B will equal mc times F all divided by ma plus mb plus mc. So that's one right there. And then I'm skipping the B part. I'm going to go to the A part. F A on B will equal the sum of the forces for A. So I'm just going to have F A on B equals MA times F all divided by MA plus MB plus MC. And that's it for that part. And then the last part, you just add those two together. So you can imagine, I'm going to start it way over here on the left. I'm going to have FB. I'm going to actually rewrite that beginning part. It's going to equal FB on A plus FB on C. Well, again, Newton's third law tells us that the opposite here will be the same, so we can go ahead and plug, where is it? This one. We'll go there. And this one will go here. So we'll have FB will equal MA times F over MA plus MB plus MC plus MC times F all over MA plus MB plus MC. We could rewrite that algebraically to read FB will equal MA plus MC times F over MA plus MB plus MC. And that's your final answer to part D. Now we are going to have to get even more room. This problem is long. Oops, what did I do there? Okay. Let's go ahead and separate those out again. All we do now is put in the answers with the mass. So basically E, oh, I kept it big, didn't want to do that. E, we have MA equals 12 kilograms. MB equals 12 kilograms. MC equals 12 kilograms. And the force equals 96 newtons in the positive direction. I'm saying to the right is positive and up is positive, although up doesn't matter in this case. Okay, so they gave you a boring situation where all the masses are equal. I don't know why they do that. It would be much more interesting if they had the masses different, especially considering they made you figure out all the equations based on it, regardless of whatever the mass would be. But we'll go forward and we'll go ahead and plug in the values. We have a positive 96 newtons divided by 36 kilograms, because that was the sum of the masses. 36 times, or 12 times 3 is 36. You already have the number I'm plugging in here comes from here. So I'm just looking at this step here and I'm filling in the numbers here. You don't need to rewrite the steps like the equation without it, because you already isolated it. You just isolated it in an earlier section. Okay, so you have the acceleration would equal a positive 2.67 meters per second squared. There's one part done. Now we got to get the answers for part C. You'll notice all the masses are the same, so we just got to find it one time and it would equal all the others. So we can even write sum of the forces of A will equal, and we're going to have 12 kilograms times 96 newtons, all divided by, and I guess we can write it out, 12 kilograms plus 12 kilograms plus 12 kilograms. So you get the sum of the forces for A is 32 newtons. Well, that means the sum of the forces for B. Whoa, why did it do that? Sum of the forces for B will also be 32 newtons. And the sum of the forces for C will be 32 newtons. Okay, nice and easy. Final step, they tell you you need to add in the forces. Now keep in mind, these equations have all pretty much been the same, so blue sounds good. These values here and these values here equaled all these values here. So the last part there, you'd have FA equals 32 newtons. FB will wait. FC will be 32 newtons. So FB would be 32 plus 32, because we said that right here that they have to add. So you're going to get 64 newtons. Okay? So you have all your answers there. The only reason you can do it fast like that is because they gave you the same masses. Okay? Otherwise, you'd have to do them separately, figure out what's the different masses. But since the masses are all the same, they made the problem pretty boring, in my opinion, doing it that way. Then you can know that those values will equal and makes the problem a little faster. But considering you did all that work for A through D, it seems like a cop-out to give you guys all the same mass, but I didn't write the book. So that concludes this video. It's a long one, but definitely make sure you understand how to go from the free body diagram to all those pieces, as that part of the problem is good. It's just a bummer that they don't give you different masses at the end. So